Hi, everyone. My name is Jonathan Kader. I lead our product and analytics team here at Quvia. Today, I'm going to be talking about our product called Network Capacity Controller, or NCC. Specifically, we're going to be focused on two new features that we've delivered in the past couple quarters, one called consumption-based management and the other called dynamic bandwidth switch. So I'm going to start the call today and the webinar today by going through some slides, giving a high-level overview of NCC, how it interacts with our grid product, which some of you may already know about, but I'll give a brief overview of that as well. And then I'll go a little bit deeper into these two features, and then we'll have Benny come and join us at that point to answer any questions that you all may have or that I have for him on how this product works and what value it gives to our customers. Cool. So what is NCC, or Network Capacity Controller? So NCC is an intelligence layer that sits on top of our grid product. Grid already does a great job of optimizing the quality of experience at the edge by reacting to real-time inputs, things like demand at a traffic class level, or system performance like packet loss, latency, or the CIR, MIR of the link. What Grid doesn't have and what NCC does is it zooms out and it gets to see a lot more contextual data and has contextual awareness of things like demand at the ship level, across fleets, what type of plan that you're on. For example, are you on a quota-based or consumption plan, or are you on a fixed rate plan? And it then optimizes your network in conjunction with Grid to improve the quality of experience and ensure good networks. So I'll dive a little bit deeper here into how NCC and Grid work together. I sort of mentioned this a bit on the last slide, but at its core, both of these products are meant to optimize the quality of experience, right? So I'll start on the right-hand side with Grid. So we're working to optimize the quality of experience, and on the local side, on the ship side or on the energy rig, wherever we are deploying Grid, we have a view into the demand, right? And more specifically, the demand by traffic class. And at Quvia, when we say traffic class, generally what we're talking about is some way of differentiating different types of traffic. Traditionally, we do this with some combination of VLAN, so passenger, crew, corporate networks, and the type of traffic being run over that VLAN, right? So you would see like streaming traffic going over a passenger network, or a low priority file transfer going over the crew network. So we have visibility into the demand, all of those flows coming from the edge to the cloud and back from that cloud to the edge. And on top of that, we have real-time visibility into the WAN side, right? So the links and the systems, the providers, and their performance. That things like latency, packet loss, the CIR or MIR for each individual terminal and for the site, as well as the billing type. So Grid is making real-time decisions to optimize for that quality of experience based off of that contextual awareness that it has. And as I mentioned, NCC takes that one step further and it gets a bit higher level, right? So you can see on the left-hand side, we'll see demand at the ship level. And that's going to be demand aggregated, not by individual traffic class, and in the upstream and downstream, right? So we'll be able to see the patterns of demand and whether there is, more demand in the upstream and downstream at a specific time of day. You'll be able to see things like the fleet-wide CIR or MIR if you have like a bandwidth pool with a provider, as well as a consumption pool and an understanding of what day of the month you are within your consumption plan, be that for an individual ship or across a fleet. And the billing type, right? So you can imagine that the decisions that we're making are slightly different. Grid is a bit more real time based on the information we have in that moment, and NCC is taking a broader view, looking at historical trends, looking at itineraries and the different types of plans that you have on board. So there's two key use cases and features that we're going to dive a bit deeper into today on the NCC side. We have dynamic bandwidth switch and consumption-based management. So I'll start first with dynamic bandwidth switch. So to take a step back, in our industries today, predominantly you can buy certain types of plans. This one really is helped to manage a fixed rate contract. So imagine you're a ship owner, and you're procuring 300 megabits per second or 500 megabits per second in a fixed rate plan, right? Generally speaking, there's nothing stipulating in that plan that if you're buying 300 megabits per second, that 200 megabits per second needs to be in the downstream and 100 megabits needs to be in the upstream. But the way that we've managed these plans today is, generally speaking, you set that static threshold, 200 megabits in the downstream, 100 megabits in the upstream, and you would either manage to that if you don't have grid, or grid would manage to that if you did have grid. But what we've noticed with our customers as we look at the data over time is that demand fluctuates in the upstream and downstream, right? There are going to be certain times of the day where your upstream is totally congested, yet you have extra capacity in your downstream, or vice versa. And again, there's nothing really technically blocking us from being able to manage those and change those thresholds. We can do that today. It's just not able to be done in real time. So what NCC does is it's able to do that in real time. It can see the demand patterns in the upstream and downstream and dynamically manage that upstream and downstream ratio in real time in order to optimize for the quality of experience of that aggregate, downstream and upstream demand. And in this next slide, I'll show you sort of how that looks, right? So on the left-hand side of the screen, you'll see before that red mark, what a network would look like before DBS is enabled. And on the right-hand side, you'd see what it looked like afterwards. So you see that yellow line, that's what we call like the CIR, so the committed information rate. Technically speaking, it's not that, but it's really like what grid is looking at as the limit to the amount of downstream and upstream throughput that the aggregate systems can support on a ship or an energy rig. And what we can see here is that the estimated allocation, which is a measurement that grid does to understand like how much can the system support at that time, is showing that it's basically hitting CIR, both in the upstream and the downstream. But what you can see with the dark blue line, the throughput line, is that there is some latent capacity, both on the downstream and the upstream on the left-hand side, right? We're not getting up to that estimated allocation. Now, what we'll see when we enable DBS, right? You can see on the downstream side, before DBS, there was a little bit of latent capacity. We enabled DBS, and something must have happened on the ship, or there was some system that needed to sync data back, or people were sending a lot of videos. But basically, NCC then sees, okay, there's a lot of demand that's needed, that's going in the upstream, and we need to be able to support that demand. So what you'll see is NCC will basically dynamically change what grid sees as the CIR, and it'll allow estimated allocation to go above that yellow line. So we can see right after DBS is enabled, there's an initial bump and then a second bump, and on the upstream side, and you'll see on the downstream that the allocation actually goes below CIR into two separate bumps. And you can see that throughput on the upstream is actually going above the CIR, and it's allowing to flex up in order to serve a use case. So what are some of these use cases, right? So some of the things that we're seeing over and over again in the market are optimized edge to cloud sync, right? So you're an energy rig, oil rig, or a cruise ship, or a commercial container ship. In this day and age, more and more data is being generated at the edge, and a lot of that data either can't get synced back to shore, or you're using physical hard drives, sending people to ships to remove data or put data on. But because of dynamic bandwidth switch, whenever there's latent capacity in either direction, we can enable services like this that can take data from ship to shore or shore to ship. Similarly to that, we can do things like prioritize corporate network syncs overnight. So during the day, if passengers and crew want to be using services on the internet, we can know that overnight there's going to be some latent capacity, and if corporate networks need to sync a lot of data back to shore or get applications from the shore to the edge, we can enable that when there's latent capacity in the system, and we can dynamically move in the upstream and downstream to maintain the quality of experience that's needed. And then the last one would be for example, to maintain performance of critical services. So we would, for example, be able to, if there is an emergency, let's say on an oil rig, a fire, or something breaks, and the cloud side or the shore side wants to be able to see video in 1080p in real time. If the network today couldn't support that in the upstream, we can basically dynamically increase the amount of upstream throughput to maintain that 1080p service, so that people on the shore side can more easily understand what's going on during an emergency. So we'll come back to DBS as I bring Benny in later for the Q&A. But for now, I'll move over into consumption-based management. So DBS, it makes fixed capacity plans dynamic, whereas CBM solves a slightly different problem and challenge, and that's really to manage quota plans. So as I started on the DBS slides, a lot of our customers buy fixed rate contracts with providers, but a lot of our customers also buy consumption-based plans or quota-based plans. So you may be a cruise ship that was contracting a 20 terabit plan with a provider, and that plan refreshes every month. And that plan has overage charges. If you go over it, those can amount to tens of thousands of dollars a month per ship if you're not managing your plan well. So basically, there's a few ways that our customers have managed these without CBM. One would be set really conservative throughput caps, so that you're going to stay under that, for example, 20 terabyte plan. And basically, that would amount to wasted capacity a lot of the times at the end of the month, or a lower quality of experience than you would be able to provide or would want to provide. Another option is let it run freely, right? Don't set any throughput caps, don't block any applications, let your users use the network as they want to, and either oversubscribe to a higher plan in order to support that you don't really need to support quality of experience, or get hit with huge overage charges late in the month. So either way there, like you're supporting the quality of experience, but you're spending way more money than you need to. And the last one's sort of like this hybrid approach where you'll see some customers are either like have someone who is manually like watching these plans over the course of the month and making sure, okay, like, oh, there's only 5 days left of the plan, but we only have a terabyte left. Like, what are we going to do? Oh, we have to remove Netflix from over that link, or Facebook, because we know that takes a lot of consumption. And then your users are seeing large differences over the course of the month in the quality of experience, right? Certain applications would work well earlier, and then later in the month, maybe they wouldn't. Or certain people have access to certain types of networks early in the month, and then later in the month, they don't. Now, with CBM, we can approach this in a totally different way, using machine learning algorithms and AI to understand things like forecasted demand, and looping in all this contextual data that we get, including like itinerary data, historical data, and even real-time demand data, so that we can optimize, again, for the quality of experience over the life of the plan. So I will now move to, so why do we use CBM, right? And I've mentioned a few of these in the last slide. First of all, it's really just to manage these consumption-based contracts without a human in the loop. It makes our customers' lives a lot easier. It means that they don't have to worry about overages. It means that they don't have to worry about someone keeping tabs. We do it for our customers, and we do it individualized, right? For each individual ship, if there's a ship that has certain consumption patterns because of the type of customers that they have, or the type of itineraries that they do, we're aware of that, and we're able to predict over the course of the month how much capacity is needed in the outer days and save capacity for that time, which allows us to, again, enable a consistent QoE throughout the month. So your passengers who are sailing with you early days of the month aren't getting a better experience than those at the end of the month, or your crew who's there the entire month isn't seeing this big fluctuation between, early month and late month in terms of the quality of experience of their networks. And again, all of this is done in the context of we still need to be able to meet the demand of the highest priority traffic in real time, right? We still have grid in line. We still understand the demand for individual applications. And so we're able to really support those prioritized traffic classes, be that like a passenger streaming or a crew member WhatsApping their family at home, and maybe deprioritize some of those traffic classes that don't need to be as real time, or put those over links that are not consumption-based links. So to wrap this up, right, NCC and Grid, they're part of the same product family here at Quvia, which is really network orchestration. And network orchestration with at the heart of it, the quality of experience of the applications and the users who are using that internet. NCC is this higher level intelligence layer that sits on top of Grid. And two of the core use cases, DBS, makes fixed contracts flexible and enables totally new use cases, which I'm excited to talk to Benny about. And CBM makes our quota plans intelligent, allows our customers to more seamlessly manage very complicated plans to manage prior to using NCC. So yeah, at this point, I'll bring Benny into the conversation, and yeah, we'll take it from there. Hey, Benny, thanks for joining. For those of you who don't know Benny, Benny is a co-founder and CEO of Quvia. And as we just walked through a bit of a high-level overview of, Grid and NCC, and more specifically CBM and DBS, I'm going to ask Benny a few questions to dive deeper into those topics, so you guys can understand how he's viewing these features and how they fit into our customers' needs and networks. And then after that, we'll take some questions from you all in the field watching the webinar. So yeah, thanks, Benny. Before we get started, I think we talked a lot at the high level of what these features are, how they're used, but I would like to get a bit more specific with you. We have these tools in production today across many customers. Was wondering if you could talk about, for both dynamic bandwidth switch and consumption-based management, how are our customers using these tools day to day in their networks? What are some interesting or unique use cases that we've seen or unlocked because of them?
Yeah, I think a good question. With regards to DBS, dynamic bandwidth splitting, we have seen use cases in a wide variety of spectrum. In one end, I would say people just were tired of the operational hassle of figuring out the up-down bandwidth ratios. Oh, is it 2:1? Is it 3:1? Is it 2.5:1? And then there was a lot of debates and arguments, and as and when they would get operational complaints from the field, they would doubt, is it the ratio that is wrong? Is it the capacity that is wrong? So DBS kind of helps them, to get rid of all of those hassles, operational hassles, basically saying, hey, it's QoE based, which basically adjusts itself the up-down ratios. So we have seen that as in itself as like, hey, that's great that you guys have this, because we go through a lot of operational hassles. Because the moment you have to decide a specific split, you then have to configure it. When people configure it, people miss numbers, and there is like configuration operational hassles and whatnot. And to the other end of the spectrum, we have seen people think, oh, this is going to enable me to do new things that wasn't possible. Example, customers trying to offload data to the cloud, looking at, hey, oh, with this feature now I can offload more data for the same spend that I have every month. Or I can bring data back from the cloud, media content and whatnot, again, for the same spend. So we've seen both ends. Just which helps me reduce operational hassle to, oh, it unlocks a lot more opportunities than what I thought. So I see DBS more as an enabler, and I think we will continue to see more and more use cases evolve out of this. So super excited about to see more of them evolve in the field with the customers.
Cool. Yeah, thank you. So yeah, let's moving on to, I guess, a little bit more on the CVM side. So could you dive deeper for us into how this predictive intelligence works, right? Like how does CVM know that if I'm on day 13 of my plan, I can only use 55 gigs versus 100 gigs versus 500 gigs of consumption, when we don't know exactly what's going to happen the rest of the month? And to dive a little bit deeper into that, what happens if we're wrong with that prediction for that day?
Yeah, I mean, in zooming out, I think we just have to be clear that CBM doesn't magically create bandwidth. So of course, if the demand is there, quality of experience cannot be met within that. At some, there is a moment where you will get alerts saying, "Hey, we won't be able to meet the quality of experience target." So to go back to your very specific question, first, machine learning is all about different features that you can identify that helps you predict better. I think one of the things that uniquely separates Quvia from any other solutions out there is we produce high quality data around that helps us understand what is driving the demand, what kind of application categories are driving the demand, how many users are driving the demand. So we have access to a unique data set that helps us actually look through and identify critical features that are driving monthly trends. So we believe, given access to that data set, it kind of puts us in a very unique position to be able to predict more accurately. And given our QoE-based network management capabilities, where at a flow level we are guaranteeing bandwidth to certain types of flows, a combination of that helps us do certain things that the industry has been trying to do for many, many years now. So that's kind of, in a nutshell, access to unique data sets and ability to manage flows based on QoE kind of puts us in a very interesting spot.
Cool. How do these features work? What do these features mean for the SATCOM providers? How should they be thinking about this as we're enabling, CBM or DBS or other NCC features?
I mean, specifically for SATCOM providers or SATCOM integrators, system integrators, they should be looking at this as a toolkit for launching new products that they weren't able to do before. So of course, as I said, with everything that SpaceX did to the industry, amazing. I mean, it was probably the best thing that happened to the industry. So with that, plus what we are doing on CBM and DBS, I think SATCOM operators should look at, okay, how do I now then launch new offerings to my customers, be it combining 5G with Starlink or Wi-Fi services at port with Starlink. How do I offer unique solutions? Is certainly something that we unlock here. We are also having very interesting conversations around doing different kinds of beyond just unique products. How can they use it to offer end-to-end solutions, like per user billing and whatnot? So suddenly the CBM unlocks new, so in one end, just new products capabilities. On the other side, new ways of offering end-to-end solutions. Like as I said, instead of charging always by consumption, by per ship, per user, you could do like different types of billing where you're offering unlimited services per user per month. Those things become possible now.
Cool. So I'll do one more question before we start to move into the audience questions. I was wondering, like, do you have an idea of what the roadmap looks like for these features? Like, what do we want to tackle next with DBS, CBM, or products that sit on top of those features?
As I mentioned before, DBS, CBM, everything that we're doing with NCC, while it's more an enabler, it in itself is not the end solution. What we are looking forward is kind of tying this up with other things that we have worked in the past, like network APIs, to say, okay, what if network API can trigger a workflow that will dynamically provision certain changes, be it to CBM or DBS, and what would that mean for the end customer? So what we are focusing on right now is what are the second order impacts of these features. If customers don't have to think about this anymore, it certainly should have second order impacts, and those second order impacts could be way more, new use cases, things. We are heavily investing into dynamic edge cloud data sync opportunities, which I would say that we are just scratching the surface. We are seeing so much excitement in the industry across cruise, ferry, energy, even shipping, where customers are like, "Oh, we never thought that these things are possible now." So super excited about it. But again, in a nutshell, it's all about what are the second order impacts in the industry in terms of use cases, or combining CBM DBS with network APIs, or CBM DBS with Q. So those are things we're going to explore, and really excited about those second order impacts and opportunities.
Yeah, it's been really cool to see how these features are so new. We really just deployed them this year, early this year for CBM, and maybe at the end of Q1 for DBS. But like, how our customers have thought about their networks has significantly changed in the last couple months.
Yep.
And so, yeah, I'm also very excited about the future roadmap. Cool. So I'm going to look at some of the questions that we got from the audience. The first one, which, funnily enough, I don't think I mentioned at all during the slides, but it is a very important use case for CBM and DBS, which is, can CBM and DBS be applied to pooled bandwidth across ships, or is this a per ship or per node feature?
It can certainly be applied for pooled bandwidth. It can be applied for single ship use cases as well. So it is applicable for both fleet and single ship use cases.
Yeah, cool. So this is a bit of a tactical question. It's so it says basically, let's say there's a doomsday scenario and a terminal is taken offline, right? So we can sort of make up what the network would look like there. Like maybe we have CBM with a 5 terabyte plan, and then a metered Neolink or a metered Geolink, and that site fails. There's a technical issue. How does our system react to that using CBM or DBS? We only have now the non-metered, the consumption-based link left.
Very good question. So as I always say, we don't create bandwidth. We don't physics is physics, but the system can do a lot of cool things. So we have seen customers where they would have a consumption pool across few terminals, and you could see the system actually utilizing the rest of the terminals, still hitting the consumption targets. So you're not. This is, as in contrary to what people would traditionally do by statically doing traffic shaping rules and whatnot on each of these terminals. Assume a terminal goes faulty or a switch goes faulty that takes out a few terminals. Instead of 4, you have only 2. The system is smart enough to orchestrate towards that consumption target across the remaining terminals. If you have an unmetered link, which is based on CIR, MIR, and a metered link, and you lose the metered link, because everything is QoE based, of course, you will see a surge in the metered link usage, in this case, where the link that is built based on consumption. And then, of course, the system kind of reforecasts itself under the assumption that we don't know the future, but under the assumption that this is not going to be available. Now, of course, the user has many options in their hand, right? They can increase the targets, or because you're getting well in advance, you're very clear you're going to breach your consumption targets. The user gets to pick if they want to increase it or if they wanted to compromise QoE, or to manage costs. So those levers are up to the users to use. Again, the biggest difference is the users don't have to statically do these traffic shaping limits and configure different terminals in different ways to accommodate to meet their cost goals. So what the system does under these different conditions, specifically on operational failures, hardware failures, and whatnot, is dependent upon how the system is set up. Like, do you want to maximize QoE, not worry about cost, or do you want to have a baseline QoE after which below which cost doesn't matter, but above which cost matters. Those things are all up to the user to set.
Yeah. Yeah, there were a couple of questions that were in that similar vein. So for example, one was like, let's say at the beginning of the month, there is a really big event, right? Like the World Cup is at the beginning of the month and everyone wants to stream it. So what you're saying is, as an operator or between Quvia and the customer, we can say, we know the World Cup is happening. We know there's going to be a game and everyone's going to want to stream it at the same time. Maybe we're okay going over our quota for this month, so we let it sort of run a little bit more. Or we can say we don't want to go over it and we're going to limit the amount of bandwidth, and maybe not everyone's going to get the best quality of experience, but we can manage that with the customer, right?
Yes. So, I mean, this is something we have seen in the industry today, right? There was a cruise customer who had launched a promotion, and it caused a spike in consumption, and the system kind of was able to manage it. Now, there are such spikes or events that we can predict and events that you cannot predict. Like, for example, awareness of port day versus sea day in the cruise industry is a feature that the system can model well. But like a promotion launch on board because of a partnership that a cruise line is having with a bank or any other financial institution, we might not be able to predict, but the system can adjust to that. Now, again, as I said, you can set target QoE levels and ensure that the cost is not a constraint, or you could say that cost is a constraint, wherein then the QoE of certain quality of experience for certain users or certain traffic types or user groups can be auto adjusted to fit within the cost constraint. Again, that's kind of what the model can do.
Okay. So there are a couple questions again in a similar vein around multiple providers or allowing CBM and DBS on the same ship. So I'll try to mush these together into one. But today most people are either buying fixed rate plans or consumption plans. But let's take it, a couple years in the future. Maybe there's multiple LEO constellations online. We have Kuiper, Telesat, we have OneWeb, we have Starlink. Each of them have their own plan dynamics. NCC, will that be able to manage it across the different types?
Yep.
Will be able to understand the full context, or does it only work with one type of plan per ship?
Yeah, I think there are two parts to that question. I want to answer the first part differently. The first part is customers do certain things certain ways with the tools that they have in their hands today. What CBM and NCC brings to the toolkit is certain things that wasn't possible before. So now it's becoming possible. So again, as I said, we believe customers' habits will change because of it. For example, if you look at traditional cloud procurement, there are baseline commits that customers do, and then there is surge usage that they do. Fixed rate contracts and consumption-based contracts kind of bring that to the table, right? You could have certain things you can commit, or you could surge into peak usage by consumption-based billing. So those things were not possible because customers didn't have the toolkit to do that effectively. Now, again, CBM and DBS brings that to the table, so we believe that it's customers can use them more effectively and unlock new use cases. On the other side, as more and more constellations go up, it looks like Kuiper will, as they're launching more satellites, should be online soon. As more constellations come up, customers can take the same use case into having it across more constellations, which is basically consumption pools versus guaranteed data rates versus guaranteed data rates with an option to surge. So what CBM and DBS does is helps customers mix and match these options, again, to manage cost and maximize performance. That's end of the day, that's what matters for the IT teams, right? How do I manage my costs? How do I maximize performance to deliver the business outcomes that I'm trying to deliver? So, and I think while CBM unlocks those use cases as new constellations come online or new pricing models come online, we also believe even within the existing portfolio that the customer might have, customers can start thinking of new ways of putting things together.
Okay, cool. Thanks, Benny. There are a few more tactical questions here that I think we'll probably answer, with FAQs online. But I wanted to ask you probably one last question before we need to wrap up. How do you think about this product and product suites place in the industry long term? What do you see this doing to our end customers' networks and end customers' IT stack in the next 5 years? I know we've talked a little bit about some of the near-term use cases with edge cloud data sync, but what does that really mean, right, for the IT org, for our customer, especially in the world of generative AI agents and things like that?
So one common thing that we are seeing in the IT stack today is AI inferencing at the edge, model training in the cloud. I mean, these are two common things you hear over and over again. So they want to deploy small language models on the edge to do fast inferencing, but then they need an opportunity to take the data to the cloud so they can train models, newer models, and then push those models out to the edge. So in data centers, what AI did is significantly increase east-west traffic. But in cases where there is AI inferencing at the edge, we believe there will be a significant movement of data between edge and cloud. And assume edge is becoming more and more mature, though fragmented. There are new use cases evolving in the edge. Cloud is already an established market. Most of the developers and applications are used to it. And now you're trying to move data between edge and the cloud. And I think that fabric between edge and cloud needs to be equally elastic, agile, scalable, without customers having to worry about cost. And I think all these constellations, as they come online, including Starlink V3, which is going to launch a lot of capacity, it's going to unlock a lot of capacity where edge and cloud can seamlessly play well, and data can move between them in seamlessly. So what CBM DBS with CBM and DBS, and probably a few more things that we will be announcing soon, we are working towards, okay, how do you unlock more and more capabilities in that area so customers can probably move more data from edge to cloud as needed programmatically. And again, software-defined storage is getting mature more and more. So people should be finding more effective ways or efficient ways or smarter ways to move data. And the same way from, again, how do we then move models once they're trained? How do we move those models from cloud to the edge and make it very programmatic? Without right now, there is a lot of configurations, people setting up templates, people setting up if-then-else rules. And I think we want to get rid of all of that. And I think the fabric can be programmable, scalable, elastic, and CBM and DBS are some of the building blocks in the bigger vision that we're building towards, where that edge cloud fabric should be agile, scalable, elastic, secure, and I think that's what we're moving towards. And again, in the next near future, we should be announcing more partnerships around, okay, how do we work with more satellite constellations to do steerable services, and what those capabilities will unlock newer use cases that, again, that we are equally excited about. So it's going to be around this theme of building a fabric between edge and the cloud to move data seamlessly, programmatically between them. That should, again, unlock more and more AI ML use cases, which is very exciting given how the models have become more mature, availability of compute, and all the business use cases it's going to unlock.
Cool. I think that's a good place for us to probably wrap up. I don't know if there's anything last you want to say to our audience. If not, we can.
Yeah, I mean, first, I always thank our customers, right? None of these features were created in a vacuum. It is not that a bunch of scientists didn't sit in a room and stare at the wall and think. It's always the customers that push us to innovate. And even both of these use cases were driven by customer needs, where customers said, just tired of this. Can you do something about this? Why don't you guys figure out a way to make this simpler, easier, faster, better? So always thanks to the customers that make us innovate, help us push boundaries, push us to push boundaries. On the other side, to everyone else out there who's still fighting with chisels and knives, I think there are better toolkits out there, more sophisticated toolkits that can unlock more value. I think with SpaceX disrupting the ecosystem, I mean, there is never a better time. There are so many new use cases that customers can unlock, and I think Quvia's work around CBM, DBS, our focus is we want to be one of the tools in your toolkit, and I think we can unlock more value. And looking forward to working with more customers out there.
Cool. Well, thank you, Benny, and thank you to everyone who stuck through and watched the webinar. If you guys do have any additional questions, please feel free to reach out to either Benny or I over LinkedIn, email if you can find it, or to our website. But yeah, we appreciate your time, and have a good rest of your day.
Thank you. Thanks, everyone.